This question is on the topic of chemical bonding, and the concept that's being tested is on how to deduce the chemical formula of an ionic compound given the description of how the ions are arranged in the lattice structure. Okay, so firstly, how do I know there is an ionic compound? It's already mentioned in the question that X contains a lattice of positive ions and negative ions. So it's very obvious that we are talking about an ionic compound. The next thing that we need to take note is this, that the compound X, the ionic compound X, contains metal Y and non-metal Z. So Y is a metal and Z is a non-metal. Now, if you can recall in the writing of the the chemical formula for ionic compounds, we always write the symbol of the metal first, followed by the non-metal. That means that the ionic compound will have a formula where Y comes in front of Z. So that will effectively allow us to rule out options C and D. Okay. Next, in order to know the formula of the ionic compound, we need to find on average for each Y ion how many Z ions are there. Right, for that we need to look at the description of the ions in the lattice. Now, before we go into that, we have to recall that metal atoms, they tend to lose electrons, and when they lose electrons they form cations. Non-metal atoms tend to gain electrons, and when they gain electrons they form anions. So positive ions we will be talking about Y, and negative ions we will be talking about Z. So now we need to look at the description of the ions in the lattice in order to find the average number of Y paired with the average number of Z. Alright, what is saying over here, the next line is this, that each positive ion is surrounded by 8 negative ions, and each negative ion is surrounded by 4 positive ions. Alright, so in the lattice, on average, we have 1 times 4 is 4, 8 times 1 is 8. So on average, 4 positive ions will be paired with 8 negative ions. And the simplest ratio is 1:2. So what it means is that for every Y ion, it is paired with 2 Z ions. That would make the formula of the compound YZ2. So the answer is B.